So this is part 2 of our experiment. This is the parallel setup of our resistors. Now you're going to go ahead and set up your circuit as shown in the diagram. This is a similar circuit to what you have in your diagram. You are going to include your ammeter. After your rheostat, we have this section where our ammeter is now at as section A, this branch on top as position B, position C would be this middle branch here, and position D is our branch down beneath. Let us read the procedure. Part 2 of the procedure, number 2, step 2 says close the switch and adjust the rheostat so that a large amount of current is flowing, but not exceeding the range of the ammeter. So I went ahead to set my rheostat. So we're using this resistor as a rheostat to 2 ohms. So I'm getting 1.18 amperes. Set your resistance to 2 ohms also. Part 3 says we should record the current reading in the ammeter at position A. So you're going to record this in a table. The next step is to change the position of the ammeter to position B, then C, then D, and also E, which is over here, and record the current reading in each instant. So let me go ahead and do a demo of that, where I am going to take the ammeter out of position A and insert it at position B. So let me put it right here at position B. So I have to disconnect the connecting wires and insert my ammeter right there to get this current reading. As I said, when the connection is made, the color will change from red to black. Alright, so that's the neatest. I'll get it here for now. And you record that current in a table. You do the same thing for position C, position D, and also position E. After we have collected that data, we have a data analysis to do. The first question in the data analysis asks, in which branch, B, C, or D is the current flowing the largest? Then it asks, why is this so? So you will state, then explain why it is so. Number 2, what is the value of the current entering junction 1? And on your diagram, junction 1 is right here. So what is the value of the current entering junction 1? Then question 3, what is the sum of the currents leaving junction 1? So that would be right here when they are leaving junction 1. So all these currents enter junction 1 and now they are leaving junction 1 through the branches. 4, what is the sum of the currents entering junction 2? Our junction 2 is over here and our currents are entering junction 2 from these resistors. 5, what is the value of the current leaving junction 2? Again, junction 2 is here. What is the value of the current leaving junction 2? 6, what can you deduce about the current entering and leaving a junction? What is the relationship between the current entering the junction and the current leaving the junction? Based on the other questions you have answered, what can you deduce? 7, by using the equation voltage is equal to current times resistance, calculate the voltage across each of the resistors in the branches. So you're going to calculate the voltage over this resistor at the branch at top, then the middle branch, and then the voltage across the resistor at the bottom branch. And you know how to connect your voltmeter in order to read the potential difference. 8. What can you deduce about the voltage across each branch in a parallel circuit? So now we're looking at voltage in a parallel circuit in each branch. What can you deduce about the values of the voltages? 9. Why should the connection for domestic appliances be in parallel? Why? We discussed that also. Now after you have done with your discussion questions and also your calculations, you will need to write some sources of error that may cause your values not to be so correct. You're also gonna describe any limitations, list any limitations and also precautions that you may take in completing this experiment. And that's it for the experiment.